Good evening, students. This is Professor Rogers. Thank you for attending this virtual lecture. Tonight we'll be going over file reading basics, token-based and line-based, and advanced file processing. This is lecture 9. Sorry about the technical difficulties. I'll continue. Hopefully you've read Chapter 6, File-Based Processing. Topics include file reading basics, which we'll go over tonight, token-based processing, line-based processing, and advanced file processing. In order to understand file reading basics, you must first understand what a file is. A file is a collection of information that is stored on a computer and assigned a particular name. The file name is very important. You're probably very familiar with files already on your computer. And files can store many different types of information and data. They can include your program code. For example, a lab5.java file would contain program code, could contain compiled programs. Lab5.class would be an example of that. You can have audio, image, and video. This particular recording will be stored as an MP4 file. You could have documents, whether they be text documents with a TXT file extension or a Word doc with a DOC or a DOCX extension, etc. As I've said, files typically have what is called a file extension. That's how the operating system, the thing that runs your computer, can understand what a particular file is meant to hold and is meant to do and be used for. For example, a .txt extension is a text file. As I said before, Java files and class files are the source code and the compiled bytecode for your file. DOC, XLS are Microsoft Word and Excel format. Then you have different binary formats like the Adobe Portable Document File, which we euphemistically call, or for short, call a PDF. There's MP3, JPEG, ZIP, HTML, EXE for executable, and thousands of other file formats and file extensions. In Java, just like we have the scanner class and the string class and other classes, there is a file class that you must import. It's part of the Java IO namespace, and you would import it by adding an import java.io.star, or you could include import java.io.uppercase file at the top of your Java class, and that will allow your program to work with files. The file class, when used, is used to create a file object, and the file object is just that. Since it's based on a class, you can utilize the file object and any of its methods, and there are many methods, and here's only a few. There's a Boolean method called canRead. It returns a Boolean. It will indicate whether or not you can read the file. There's a method called delete, which will delete the file. So be very careful when actually using that method or calling that method. There's the exists method, which will tell if a file exists. And that's very useful to check before reading from a file. There's also a method called getAbsolutePath, which will return the path or where that file resides on your computer. GetName will return the name of the file without the path, without the directory where it's found. IsDirectory is a Boolean method which will return if the file and the path actually represents a directory and not a file. The corollary to that is the method called isFile, which will return a Boolean to indicate whether or not the file object refers to a file. Length returns the size of the file in bytes, and rename to will change the name of the file. The great thing about reading from a file, you can write a program that will read from a file just as if it would be reading text or data, strings, numbers, and so forth, just as it would if you were reading from the console. So you still use the scanner object, and you use all of the methods of the scanner object, which you have come to understand, like has next and next for reading words from a line, next int for reading an integer, and so forth. And let's jump right into an example called count words. And I'm going to go over to Eclipse and walk through that particular program. Count words is a very simple program. We can see that the java.io.star is imported. The name of the class is count words, and there's only a single main method. The syntax that you use for declaring a scanner object that reads from a file is exactly the same syntax that you use for reading from the console, with the exception of including inside the new scanner constructor, inside these parentheses, I've highlighted something different. It's the keyword new, the class file, and then the constructor to the class gives the name of the file that you wish to read. In this case, hamlet.txt, txt. If we look at the current working directory of the count words program and the count words project, we see that there is, in fact, a file called hamlet.txt. And if we were to click on that file, we'll see that it's actually the entire play of William Shakespeare's Hamlet. It's one line for every line that you would expect in a play, and there's over 5,800 lines in this file with all the various dialogue for each of the characters in the entire play. Not a large play, but an interesting play. Hopefully you've had to read it. Now back to what the count words program does. It creates a scanner for reading a file, provides the file name. The name of the file scanner is called input. Then this looks a lot like a cumulative algorithm. Why do I say that? Because we see that there's an initializer. Something's going to be initialized and then computed within a loop. And then there is a while loop. This while loop will continue. It will check, is there a next input? Input.has next. If there is, if that's true, if there are more words in the input, then just like a cumulative algorithm pseudocode would dictate, the first statement at line 13 within that loop is to get or obtain the next word. And we do that by declaring a word string and setting it equal to input.next. Again, the while loop, the test condition says there is a next and you'll obtain next. We print out the next on its own line, the next word, and then we increase the count of the number of words. And we'll continue doing that. We'll continue reading in that while loop as long as there are additional words to read in the file. When there are no more words to read, input.hasNext will return false. The while loop will end. We will close the input stream or the file, and we will print out the total number of words found. So let's run this. It's a lot of output, one line of output for every word. If I scroll all the way to the bottom, we see that the total number of words in the play William Shakespeare's Hamlet is 31,956. Runs pretty quickly. I'll run it again. 31,956. Okay, back to the notes. One of the things that you'll notice is you have to make sure that your program adds a check exception and a throws clause. One thing I'll note about that is that my main method has this throws file not found exception. If that is not there and I try to run the program, I will get a syntax error. The syntax error tells me that I have an unhandled exception of type file not found. Whenever trying to read from files, Java will force you to include these exception handling because it's a very common problem for programs to try to read a file that does not exist. Easiest way to fix that is to click on the syntax error and pick one of the fixes, and you can just add the throws declaration. So that will be there. Just wanted to mention that because that is something the book talks about, and it is something you have to do when you have programs that read from files. Another common problem that you'll have when reading from files is that you will encounter a runtime error of the type no such element exception. The count words program is rather simple because it only reads words. It uses the next and it uses has next of the scanner class to see has next to see if there's another word in the file, and then next to read that word. That is rather error, not very error prone. It's rather error resilient. Now, if you were writing a program that was reading words that could be strings of numbers and characters, or numbers that could be integers or floating point, then your program could be much more error prone because your program might try to read, for example, an integer, and the next item in the file would be a floating point number, and you would get a no such element exception. In chapter 3, you may remember that we used next int to get a next int and next double to get a next double and so forth. We can do the same thing in writing programs that will read numeric data from files. And a good example here is show sum number 1, and it's an example from the book, and I'll go through that in Eclipse right now. Again, a very simple application. There is a show someone class. Again, we've imported java.io.star. We create a scanner, which we call input, and it loads not system.in inside the scanner constructor, but it declares a new file object and specifies the name of the file to read as numbers.dat. And if we look at our Java project for show sums, we will see there is a numbers.dat. And if we open that with a text editor, we will see that there are several numbers, several doubles or floats, but they're definitely floating point numbers with some white space, blank lines, and so forth. And that's okay. It's okay that we have multiple lines. It's even okay that we have blank lines. It's very easy to write a program that will read a file like that. So in line 10, or excuse me, 11, we'll create the scanner as I stated before. This is a cumulative sum algorithm. It will be adding all of the doubles from that file. It has a for loop, so it's assuming there are 5 doubles. Remember, a for is a definitive loop. We know how many times it's going to run. It's going to run for I equals 1 to I is less than or equal to 5. That's 5 times. We're going to obtain the next. We declare double next equals input dot next double. So that will read the next double from the file. We print out that double on its own line, including the number that we're reading. Is it number 1? Is it the first? Is it the second? Is it the third? Or is it number 1, number 2, number 3? And what is its value? Next. And then we increment sum by next. And after we've read 5, we will print out the sum. So let's run the program. We see number 1, 2, 3, 4, 5. And the sum is 350.4999994. By the way, for those keeping track, that is what we'll discuss and probably already have discussed once in the class. That's a rounding error. That's happens because Java approximates the storage of doubles and floats. They're not an exact science and not an exact storage. So we would expect that 0.2 and 0.9 would be 0.11. Excuse me, 0.1 would be 1.1. Add 0.4, you're now 1.5, 0.8, 2.3, add 0.2, 2.5. So we would expect this to be something 0.5, not 0.499. That's a rounding error. If we were to print out the sum using printf with a %.1f, then it would actually print out 350, or excuse me, 0.2f, 350.5 or 50. It would round it properly, but that is a rounding error. So this works, but we can see it might be a little fragile. For example, numbers.dat has 1, 2, 3, 4, 5, 6 items in it. We're stopping at 17.2. What would happen if there were not 5 numbers that we're trying to read in numbers.dat? What would happen? Well, instead of just guessing, why not update the file and rerun? We get this no such element exception error that I talked about before. It's trying to read 5. You've told it you're going to read 5 elements, but there are not 5 elements in the file. There are not 5 doubles in the file. I could fix that by adding them back in, and then it would work. Or I could come up with a better version of show sum 1. And the book calls that show sum number 2. What if instead of a for loop that expects exactly 5 numbers, we add all of the doubles that are in the file? So regardless how many there are, if there is another double, has next double, instead of a for loop, which is definitive, it runs an exact number of times, it's a while loop. It will run an indefinite number of times. It'll run in as long as input.has next double is true, then we'll do the same thing. We'll get the next double, we'll increase the count, we'll increment the sum. Now let's run that. But before we do, let's look at what numbers.dat looks like. Oh, sorry. numbers.dat. We'll open it with a text editor. This is a different numbers.dat. This is the numbers.dat that's in the show sum 2 project folder. We see 308.2. We see this number 4, the word foo. That's not a double. So what would we expect to happen? We would expect this program to stop after the first 3. And that's okay. Let's see if it does that. Sure enough, it adds the first 3. It encounters the word foo, which is not a double. Has neck double is now false, and it returns all of the items. If we were to fix numbers.dat by removing foo and save it, and now run the program, we would see that it would run through many more and all of the numbers in numbers.dat, and the sum would be updated accordingly. So back to the notes. Again, common programming errors are reading the wrong token. You might get an input mismatch exception. Another common programming error is forgetting the new file and just putting the word in the constructor for the scanner object when declaring your input scanner, your file scanner, forgetting new file and then the name of the file and just providing the name of the file. That will be confusing, and that will work because the scanner can read from a string. So let's segue into something a little bit different. What we were talking about prior was token-based processing, reading a file a token at a time. It requires that you know the format of your file. Works very well when a file is free-formed, but everything in the file is the same type. Maybe there's only words in the file. Maybe there's only double or integers in the file. And you have to process all of those things in the same manner. Maybe you're summing them together, maybe you're counting them. That's really easy for token-based processing, and processing the entire file as a set of common tokens. Excuse me. More often than not, though, you will have files that are structured. Every line will have a specific format. Every line will have that same format, and then your program will do what's called line-based processing. It will read your file a line at a time, and then for each line, will then process that line because it knows each line has the same format, and it knows which types of tokens to find in each line and in what order. A good example of that is Hours Worked 2. It's from the book, and it uses a combination of line-based and then token-based scanning. So it'll read a line at a time, and then will process each line according to their specific tokens in each type of token. Let's go through that in Eclipse. Again, we have import.java.io, and we have a main method. A main method will read as a scanner for reading new file, hours2.dat. So we know we're reading a file, and we're going to read that file a line at a time. While there is a next line, while input.has next line, we're going to declare a string called text and read the entire line. Then that's line-based processing. So we're reading the file a line at a time. And for every line of the file that we read in, we're going to call a method called process line and pass in that line that was just read. Process line text. Before we see what process line does, let's take a look at the file hours2.dat. This file has 5 lines, and every line has exactly the same format. This is a file that holds employee work hours. So for example, I might be responsible for payroll, and every line of this file is the hours that an employee has worked for my company for this week. The first token, or the first entry in each line, is an employee number, and it's an integer. The second token is a string, and it's the first name of the employee. The rest of the tokens on each line are any number of hours, daily hours worked that week. So the first line, it's 7.5, 8.5, 10.25, 8, and 8.5. And they're all floating point numbers. Notice how every one of these lines is the same format: employee ID, employee first name, then the number of hours worked, total hours worked per day. We're not indicating which day, whether it's Monday, Tuesday, Wednesday. It's just Aaron worked 10.5 hours sometime during the week, then 11.5, then 12, then 11, then 10.5, 10.75. So that's the file. And back to the program and process line. We left off at seeing what process line does. Process line takes in a line, one line of the file. It declares a new scanner object. And this is not a file scanner. I've told you, be careful. Don't create 2 different scanners in your program. And that's correct. Don't create 2 different console scanners in your program. It's quite okay to have a file scanner in one method, like main, this is a file scanner, and another scanner that reads from a string. Scanners can read from strings. In exam 2, you'll be asked, what are the 3 types of things that you can read from using a scanner object? 3 things are the console, also known as standard input or system.in. The second is a file. The third is a string. This in line 10 is an example of using a scanner to read from a string. And you use all the same methods that you've come to know. So if the first item in the string, in every line, of that file is the employee ID, and it's an integer, then you can read that ID in as number 11. Int ID equals data.nextInt. I'm using my string scanner named data. So now I have the ID. I can then read a string and assign it to the variable name. String name equals data.next. See how I use nextInt to read an integer? Because that's an int is the employee number, the first thing on the string. The employee's first name is the next item of the string, which happens to be a next item of that line, which happens to be a string. So I use the next method to get the next string. I can then create or initialize a variable called sum, which is a double. I set it equal to 0, and I will read all of the remaining doubles on that line. While there are doubles, while data.has next double, then I will get and increment sum. I will get the next double and use it to increment sum. And lastly, when done processing that line, because I've read the employee ID, I've read the first name, and I've created a sum of all of the hours worked in that line, I simply print out total hours worked by the name of the user, the name of the employee, first name, with an ID of is, and I print that out as the sum in 2 decimal places. And then since I've said I have a string that's part of what I'm printing out, and an integer of part of what I'm printing out, and a floating point, then I have to include those same values in that same order. Name is the string, ID is the integer, and sum is the sum of the hours, which I've calculated all in this method, and I print that out. And when I do that, I will print out, essentially process and print out every line of the file. Let's see that run now. All right, total hours worked by Erica, who has an ID of 101, is 42.75. Then the same for Aaron, Simone, Ryan, and Kendall. It's a pretty cool program. Back to the lecture notes. There's also a print stream example of hours worked called hours worked 3, and it uses print stream to actually output to a file. We're not going to actually be doing any labs in this class that output to files, and the lecture notes have the example of outputting to a file. So if you want to take a look at that, you can go through the schedule for lecture 9, look at the lecture notes, click on the link for the example, and you'll see the example listed. You can also do some pretty advanced file processing things and capabilities. You can use, as I said before, the can read method to see if a file can be read. It will return true if it can. And there's an example called count words 2 that actually asks the user for the name of a file to read. And if it can read that file, it will read it. And if it can't, it's going to say that it can't read the file, and it's going to ask the user to read it again. And this is really good boilerplate code. There's a method called getInput for getting the name of the file. Again, it's good boilerplate. You could write that method once and use it in any program in the future where you need to ask the user the name of an input file and see if that file exists and can be read. Let's go through that example. This count words number 2. We see there is a method called getInput. Before we talk about that, let's jump right into the main method. Main method's going to look a lot like hours worked number 2. This is hours worked, or excuse me, count words number 2. It's going to look a lot like count words, where you have you're getting the name of a file, and then while you have that file, if there is a next, then you'll increase the count, and then you'll print out the total number of words. So it's a lot like count words, which we use to figure out how many words there were in a file of a known name, like hamlet.txt. But what if you didn't know the name? This is what getInput does. It asks the user, it prompts the user, line number 9, input the file name. So it's asking the user, please enter the name of a file. It's then creating a new file object from that file name. So we have a file object called F, and the name of the file wasn't hard coded. It's not double quotes hamlet.txt. It's whatever the user types in as the response to that input file name. It then checks the can read method of the file object, and if we can read, if it is the case that we cannot read, if not can read, then it will tell the user files not found, and it will ask the user again to input a file name. It will again set that equal to a new file object, and check with the while loop to see now can it be read. And it will just keep asking again and again and again. The name of my file in count words 2. Let's see what it is. It is hamlet.txt, but let's try running it and giving it something other than hamlet.txt. Oh, sorry, wrong file. Input file name. Hamlet2.txt. File not found. Try again. Joe.txt. File not found. Try again. Hamlet.txt. Oh, it found the file. It read it. Total words were 31,956. That's good. Okay. Back to the lecture notes. One thing about, and another topic for advanced file processing is you have to be sure you know where your files are. I kept mentioning and showing the data files, whether it was hamlet.txt or numbers.dat, they're in the same folder as your Java project. So when you create those files in a Java project, you create them just like you would a new class. Within Eclipse, you'll do file, new, untitled text file, and then you'll enter whatever text in the text, and then you'll save that file to the directory, the same folder as your Java file. That's also known as what is known as the current directory. It's the working directory that Java and Eclipse use when running your program. You have to make sure that your files are stored in that current working directory, in the same directory as your Java file. Please do not set up a file path like you see here in scanner input equals new scanner, new file, C:, my documents, my data, data.txt. Don't do that, because on your computer, that text file, data.txt, in a folder called my data might exist, but when I try to run your programs, those files may not exist. But I will be expecting to run your programs and accessing files in the current working directory, not in some absolute directory that includes a path. Same thing with a relative path. Please try not to use relative paths that might start with a period or ... which is current directory and previous directory respectively, and then some subdirectory and so forth. Again, might work for you. Your program on your computer, when you submit it to AutoLab, is not going to work. So that's the end of tonight's presentation. I hope that you have been following along, and I hope that everything has been presented in a easy to understand manner. If you have any questions, please send me an email. Please review all of the notes, the lecture notes, the examples, the samples, run them for yourself, and please work on lab number 5, and hope you have a great rest of your week. Thank you.